Hello, today we're going to be factoring out common factors from quadratics or cubic polynomials. So when we think about factoring out a common factor, really what we're doing is we're factoring out the GCF, or the greatest common factor that those terms have with each other. So let's look at this first problem, number 1 here, 4v to the third minus 4v squared. So when we think about factoring out a common factor, we want to know what do they have in common, or what do they have similar. Well, if we look at this problem, 4v to the third minus 4v squared, they can both be divisible by 4, and they both have a v squared in common. Okay. I'm just going to erase this to make this look a little better. So 4v squared is the greatest common factor that these two terms have in common. Okay, so 4, they're both divisible by 4, and they both have at least 2 v's that are in common. So I like to write them underneath each other because that's what I'm going to be factoring out. That's going to go out in front of my parentheses. So now let's figure out what's going to be inside of each parenthesis. 4 divided by 4 is 1. I had 3 v's. I'm taking 2 away, so I'm left with a v. Negative 4 divided by 4 is negative 1. Then v squared over v squared, these will cancel each other out. There's my final answer. I have just factored the greatest common factor out of both terms. So I have 4v squared, parentheses v minus 1. We'll think about, can you break this down any farther? No. This is in simplest form. Okay, and the first thing I could look, you needed to look at was make sure these are in standard form, highest exponent to the lowest. So these were in standard form because our highest exponent 3 came before the v squared. Let's try this one. First, is this in standard form? No, because our highest exponent was a 4. So let's rearrange that. So the negative 12a to the 4th is first, then minus 32a to the 3rd minus 12a squared. We wrote this in standard form because we want our highest exponent going to the lowest. Now look at all 3 of these terms. What are they all divisible by, and what do they all have in common? So 12, you could list out all the factors of 12 and all the factors of 32 and find the highest one in common. Well, just think, what's the highest number that both goes into both 12 and 32? Okay. So 1 goes into all of them, 2 goes into all of them, 4 goes into all of them. What about 6? 6 goes into 12 but not 32. So that doesn't work. 8 goes into 32 but not 12. So the highest number we're going to take out is a 4. Now we always want our term with the highest exponent to be positive, so I'm going to take a negative 4 out because that's going to make this a to the 4th going to be a positive number. Now also, how many a's do they have in common? They all have an a. This one has 4, this has 3, that has 2. So the highest number they all have in common is 2 of them. So negative 4a squared is my greatest common factor, my GCF. Now I just find what's going to be inside. So negative 12 divided by negative 4 is positive 3. I had 4 a's. I'm taking 2 away, so I have a squared. Negative 32 divided by negative 4 is positive 8. I had 3 a's. I'm taking 2 away, so I'm left with an a. And then negative 12 divided by negative 4 is positive 3. A squared over a squared is gone. There's my final answer. So here, first thing I want to do is this in standard form? No. My highest exponent is a 7, so I want to rewrite that with that first. So minus 20n squared minus 40n plus 70. Now if you're wondering what your signs are for each term, look at the sign in front of it. Here this is positive, so it's a positive 70n to the 7th. This is positive, so it's positive 70. So now what is the highest number or term that you can factor out of there? So if you're thinking, well, you know, all these numbers are divisible by 10. You can try other numbers, but 10 will be your greatest common factor. Now, do they all have n's? These first three terms do, but the last one doesn't, so we cannot take an n out. So 10 is our greatest common factor. 70 divided by 10 is 7, n to the 7th, minus 2n squared, minus 4n plus 7. There's our final answer. We've factored all those terms. We've factored a greatest common factor out. Our last problem that we'll do is factoring. Well, it's a little different directions, but what we need to do is we need to factor out a common factor first. So let's do exactly what we did for the last two, or last three. The highest number that goes into all three of these terms is 4. They all don't have n's, so I can't take any of that out. So 4, then I'll be left with n squared minus 5n minus 50. Now we can do this two ways. You could set up your two parentheses, because we can actually factor n squared minus 5n minus 50. We need to see if we can factor that down farther. Okay, so you can set it up, break n squared down to n and n. Now you find two numbers that multiply to negative 50, but then add up to negative 5. So, you know, we know 10 times 5 will equal 50. Well, what if we make one of these negative? Which one could we make negative so that it adds up to negative 5 in the middle? Well, of course, our highest number will be negative for them to add up to be a negative number. Negative 10 plus 5 is negative 5. And so we've factored that down into two binomials with a greatest common factor out in front. Okay. You could also use the box method with this. If you would like to use that, you can. Okay. It's just setting up two sets, drawing your box with 4 squares. You can always watch that video on doing the box method with this. The reason why I would not do the box method is that the only time I use a box method is when your n squared term or your x squared, your quadratic term here, if the coefficient out in front of it is greater than 1, because then that'll give you different numbers, a lot of different numbers that you could possibly use for these. Okay, so but when it's just 1n squared or 1x squared, I'll just set up my two sets of parentheses, break this first term down to n and n, then find two numbers that multiply to negative 50 but add up to negative 5. Well, if you have questions on the worksheet, please don't be afraid to ask. Have a good day.